So today we're going to start looking at reasoning and proof. So our essential question for this section is, how do you go about proving a statement? Well, you've already been proving statements for quite some time. You just didn't know it. We haven't been doing it formally. So we're going to investigate that today. So a conjecture, so I'm going to go ahead and highlight that. A conjecture is a statement that is believed to be true. Okay? You can use inductive or deductive reasoning to show or prove that a conjecture is true. Inductive reasoning is the process of reasoning that a rule or statement is true because of specific cases. Deductive reasoning is the process of using logic to draw conclusions. All right, let's talk about this a little bit. I like to look at deductive reasoning as being a detective. So I'm in the process of searching, drawing conclusions, and I finally make my statement. Uh-oh. I didn't copy that part. Okay, so complete the steps to make a conjecture. What's a conjecture? A true statement. About the sum of three consecutive counting numbers. Okay, so what's consecutive mean? One after the other, or in order. That's what I wrote. All right, so write a sum to represent the first consecutive counting numbers starting with 1. So that says a lot right there, starting with 1. So I'm going to start with 1. Go back and reread it. Write a sum. What is a sum? Adding. So I'm going to add. Write a sum to represent the first 3 consecutive counting numbers. If we start with 1, we're going to add. What's the next number going to be? 2. And then we're going to add 3. So 1 plus 2 plus 3 equals 6. Is the sum divisible by 3? Yes. 6 divided by 3 equals 2. Write the sum of the next 3 consecutive counting numbers starting with 2. So what would that be? 2 plus 3 plus 4 equals 9. Is this sum divisible by 3? Yes. 9 divided by 3 is 3. All right. Complete the conjecture. So, based on what we just used deductive reasoning, right? We're gathering facts. So what did we gather? The blank of 3 consecutive counting numbers is divisible by the sum of 3 consecutive counting numbers is divisible by 3. Do you think that would happen for anything? What if I did 5, 6, 7? What's 5, 6, 7? Is that divisible by 3? That's interesting, right? What if I did 100, 101, and 102? I'm guessing it's going to be divisible by 3, right? 100, let's say 101, 102, and 103. 306, divisible by 3? Okay. Let's move on. All right. Recall that postulates are statements you accept as true. A theorem, on the other hand, is a statement that you can prove is true by using a series of logical steps. The steps of deductive reasoning involve using appropriate undefined words, defined words, mathematical relationships, postulates, or other previously proven theorems to prove that a theorem is true. So we gather everything together to prove something, right? That's what that's saying. Use deductive reasoning to prove that the sum of 3 consecutive counting numbers is divisible by 3. All right, so let's start with S. Let the 3 consecutive counting numbers be represented by n plus 1, and n plus 2. Let's test it. What if I started with 5, if n was 5? Then what would n plus 1 be? And n plus 2? Does that work? Okay. All right. The sum of 3 consecutive counting numbers can be written as, all right, so here's this. Can't I write that as n plus 1 plus n plus 2? Isn't that writing them all together? How many n's do I have? 3. What else is left over? 3. So this is equal to 3n plus 3. The expression 3n plus 3 can be factored as, what if I factored out a 3? What would be left over? N plus what? 1. Right? Isn't that the inverse of the distributive property? You can pull out a 3 from everybody. The expression 3 times the quantity n plus 1 is divisible by what were we trying to prove? That if you add 3 consecutive numbers, they'll always be divisible by 3. So the expression 3 times n plus 1 is divisible by 3. Isn't it divisible by 3? Yeah. For all values of n. I just tested for any number I plug in there. If I want to make that 1,000,000, that would be 1,000,001 plus 1,000,002, and I know that if I add them all up, it's always going to be divisible by 3. So, let's see. Recall the conjecture in step E. Where's step E? Right here. So the sum of 3 that's what I just did, right? I recalled it without saying it. All right, recall the conjecture in step E. The sum of 3 consecutive counting numbers is divisible by 3. Look at the steps in your deductive reasoning. Is the conjecture true or false? It's true. It is a true statement. What comes next? Questions so far? Do you see how we were kind of like a detective and plugging stuff in and coming to conclusions? Okay. All right, a counterexample. Have you guys ever seen a counterexample? Yeah? I've got a counterexample. I did it in Algebra 2 today. Here's a counterexample. N, the absolute value of n is less than or equal to n. Let's try 1. Is the absolute value of 1 less than or equal to 1? Does that work? 1 equals 1, right? Let's try negative 1. Is the absolute value of negative 1 less than or equal to negative 1? What's the absolute value of negative 1? Is 1 less than or equal to negative 1? It is? It's not counterexample, right? It didn't work with a negative number. It works with a positive number, not a negative number. What about 0? What's with 0? Does it work with 0? So it works with 0, it works with 1, I bet you it works with 1,000,000. But what's it not going to work with? Negative numbers. That's a counterexample. Okay, so A counterexample is an example that shows a conjecture to be false. Do you think that counterexamples are used mainly in inductive reasoning or deductive reasoning? This is a hard one. This would be inductive reasoning. Inductive proves to be false. I may have shown you a bunch of detective work up there, but the process of just coming up with a counterexample is just, here's the facts, here's my proof. Okay, suppose you use deductive reasoning to show that an angle is not acute. Right? So we go through a bunch of things and we find out, guess what? This angle isn't acute. What does acute mean? Smaller than 90. I like how you guys use your hands. Smaller than 90. Can you conclude that the angle is obtuse? So if it's not acute, is it automatically obtuse? Why? Could be right. Or it could also be a straight angle. What's the degree of a straight angle? Okay, I think that's good for now. Yeah, we're done for today. Good job, guys.